Okay, we have another problem asking us to find a resultant vector. So I've already done one video on this in which they gave us the component forms to work with. But here you can see that my goal is going to be to use our initial and terminal points of the vectors given to then perform that same process to work with that same linear combination setup. So here we can see that they're naming our vector using 2 points. So from A to B, this vector is from C to D. And so we're going to be careful to set this up properly. We want to make sure that as we set these up that we think about the direction, the fact that they are moving from A to B and from C to D. Okay, so what I tend to like to do with these is do a rough sketch of these points. So let's say this is the point 2, 4. I'm going to go ahead and, like I've done in previous videos, I'm going to go put the letter A beside that so we know that that's the point A. 7, 6 would be off to the right and then up just a little bit. So we'll just go about here and I would call that B at 7, 6. Now, you don't need graph paper for this. Please be mindful of that. A lot of people will overdo it. They'll try to go in and make a point of getting very precise drawings. But we're looking for sketches here because we just need the basic information. We don't need this to be exact. So from A to B would look like this, the arrow pointing toward B. And what I know is that my horizontal component here and my vertical component here are easy enough to find because I know what these values are. From 2 to 7 is me moving in the positive x direction by a unit of 5. And then from here down at 4 up to 6 is moving up by only 2. So right 5 and up 2. This tells me that the vector AB, I'll write this down here, the vector AB is the vector 5, 2. I want to repeat that process with CD, and I'll go a little faster this time. So CD, let's see, negative 2, 3, that's going to be higher than the negative 5. So negative 2, 3 would be to the left and up, and then 4, negative 5 would be somewhere to the right and down pretty far. So we're just going to do a quick sketch like this. Now, if you prefer the graph paper approach and you just think that that's just the best way to do these things and you want it to be as perfect as possible, you know, everybody has their own little tendencies towards OCD, so if you want to do that, do that. I'm just looking for sketches. Now I see this to the right and down. This is going to move down and to the right. That drew that area really far down. I didn't mean to do that. We're going from a height of 3 down to negative 5, so that's dropping by a total of 8. So this time my y component is negative. And then for my x component, we're going to see here that we're still moving to the right from negative 2 to positive 4. That's a total distance of 6. So that tells me that the vector CD is going to be 6, negative 8. And there's a real temptation to write that negative 8 first, just because I wrote that down first. But keep in mind, again, you always want to lead off with your x term. If I accidentally swap these guys, I'll end up adding the wrong things together later when I multiply. Having said that, if you've gotten through the previous video, the rest of this should feel really familiar. Because all I'm going to do is apply the same process. I'm going to take these coefficients, these scalar multiples. I'm going to multiply AB, this vector here, by the negative 4. I'm going to take CD and multiply by this positive 3. And then I'm just going to add their results together. So here we go. This one times negative 4, so 4AB, negative 4AB, would be negative 20 and negative 8. And then over here, we need 3CD, so we're going to see 18 and negative 24. So double check that, look at that. If any of that is confusing or misleading, feel free to take a look, check it out, you know, rewind, pause, whatever you have to do. But in this case, we're just going to go in and add these now. So that's what this symbol in the middle is here for. We're going to take the x components, our negative 20 and our positive 18. That's going to be a combined total of negative 2. It's just a little bit stronger in the negative direction. Okay, so we have negative 2 for the x component. And then we have both negative numbers for our y component, so we're just going to combine that. If you're somebody who has trouble with adding negatives or that kind of thing, I think of negative numbers as owing something. So back here, if I owe you $20 and I pay back 18 of it, I still owe you $2. That's kind of just where my brain goes. Now, if I owe you $8 and I borrow 24 more, well, maybe you shouldn't have loaned it to me, but if you did, 8 and 24, that combined debt would be negative 32. And so we're going to see that our vector, negative 4ab plus 3cd, let me write that down here just so we're on the same page, negative 4ab plus 3cd equals the vector negative 2, negative 32. From this point on, we're just about finished with the problem. All we have to do is find our magnitude and find our direction, because notice back in the beginning, it said to give direct notation, and that refers to that setup where you list both magnitude and direction. So what we're going to do, as we've done in the past, we're going to find our magnitude by taking the square root of the sum of the squares of the components. So I'm going to square my negative 2, I'm going to square my negative 32, add them up, take a square root. And by that, I'm going to put all that into the calculator and let it do the work for me. And then to find our angle, our direction angle, it might be worth putting a little star beside that every time you work on the direction angle. So we're working in the fourth quadrant. I lied, I apologize, third quadrant. This right here, they're both negative. I saw only the one when I looked at it. Since these are both negative, we're thinking of something that's moving this way and this way, so it's going to point in the direction of the third quadrant. That tells me that my angle of measure should be a number between 180 degrees and 270 degrees. But what's going to happen is, when I go to do this, when I go to find my theta, I'll do tangent inverse of my y component divided by my x component, and the calculator is going to see this and go, well, that's a negative divided by a negative, which is going to give me a positive value. It's going to treat it just like if this was a positive 32 over a positive 2, which would be in the first quadrant. So to deal with that, all we have to do, we'll have to add 180 degrees to our answer to rotate around the circle, so to speak, into that third quadrant. So here we're going to get a value, and we'll take a look. We'll see that here in just a moment. So let's go ahead and do this. We have the square root. Now, I'm going to be a little lazy. I'm just going to say 2 squared plus 32 squared, because squaring negative numbers just results in positives anyway. So I like saving myself keystrokes in the calculator. I saved 6 different button presses there, which doesn't feel like a lot, but if you've ever had a high-stakes test, you know how much time can really matter for a lot of people. So every little thing you can save time on is actually pretty helpful. So we're looking for efficiency as well as accuracy. So having said all that, having rambled enough, we're going to see this is a little bit bigger than 32, and that should make sense because the other side of that triangle is really small, so it shouldn't have affected it a lot. I would argue probably 2 decimal places here just to be accurate. If you round to 1 or to a whole number, it's going to look like your hypotenuse is the same length as one of your legs. So we want to make a note here. This is really, I mean, it's very close, but this is what it is. And then we just go and find our angle here. Always double check. I'm in degree mode here, which is good. Let's do second tangent of that 32 over 2. Notice I'm not even going to bother with my negatives here either, knowing in my head that those negatives are going to both cancel out. And I get about 86 degrees. And so I'm going to put approximately 86 degrees. Let me scribble that there. Approximately 86 degrees. I like rounding to whole numbers here. That's just kind of a preference of mine for angles. It doesn't have to be that way. That's also only in degree mode. If I'm in radians, I really like to be more specific, just because they're kind of a weirder way to measure. Having rambled about all that, we are, though, effectively done with this problem. Our vector negative 4ab plus 3cd would in fact just be 32.06, 86 degrees. This right here would be our direct notation. We have magnitude and direction.